First things first, whenever you are performing a chemistry experiment, always remember to wear goggles and wear clothes that nearly cover your entire skin. Now, what I'm holding here is what's called a stock solution. Now, a stock solution is used so other solutions can be made with smaller concentrations. Now, our stock solution here is a 20% sugar stock solution, which means it has a concentration of 20%. We're going to use it to make solutions with lower concentrations. So what I'm doing right here is I'm pouring our 20% stock solution into a beaker. Now, we're going to inject some of the 20% stock solution into a more pipette. We're not going to inject it to the bulb, of course. I'm going to get some and then stop it with my thumb. Okay. Now, what we are going to get is what's called the initial volume reading. And if you'll notice, the top of the substance in the pipette does not make a straight line. It makes kind of a concave shape. This concave shape is called a meniscus. And a meniscus occurs because the molecules of the substance are more attracted to the vessel that's holding it, which in this case is the pipette, than the molecule itself, or the substance molecules, the substance-owned molecules. Now, if it were convex or pointed up, the molecules of the substance would be more attracted to itself than the pipette. So whenever you read the volume of a substance and you see a meniscus, you're always going to read from the bottom line of the meniscus, which in this case you're about to see is roughly 3.8 milliliters.
You want to read your meniscus?
See, 3.8 milliliters. Now, whenever you're using a Moy pipette, you're going to add one extra decimal place than the pipette reads. So in this case, if it says 3.8 milliliters, you're going to say 3.80 milliliters. Now, we're going to let out just some of our substance into a volumetric flask. We're not going to empty out the entire pipette. And we're about to get what's called the final volume, or V final. And once again, read from the bottom of the meniscus. As you can see, it's roughly 6.3 milliliters. We add the extra decimal place, and we get 6.30 milliliters. Now, in order to calculate the volume that was delivered into the volumetric flask, you're going to do V final, which is 6.30 milliliters, minus V initial, which is 3.80 milliliters, equals to roughly 2.50 milliliters, which is the volume of the substance that's inside the volumetric flask. Here you can see a visual representation of our volume equation. See, we have V final, which was 6.30 milliliters, minus V initial, which was 3.80 milliliters, equals to the volume delivered into the volumetric flask, which was 2.50 milliliters. So 2.50 milliliters is the volume of our substance that's inside the volumetric flask. Now here we are doing what's called a dilution. And a dilution is when water is added to a solution with a set concentration in order to lower the concentration of that solution, which in this case, our set concentration is 20%, and we're adding water to lower the concentration. Now, there is a way that we could estimate the new concentration, which is called the dilution equation. And basically, it goes C1 times V1 equals C2 times V2. The first concentration times the first volume equals to the second concentration times the second volume. And algebraically, we can either solve for the second concentration or the second volume. Scenario where our second concentration is 15%. So here we have the first concentration, which is 20%, times the first volume, which is 2.50 milliliters. And like I said, we're using a hypothetical that our second concentration we know is 15%. So to solve for our second volume, you're going to divide both sides by 15. So you have 20 times 2.50, all that divided by 15 makes V2 equal to roughly 3.33 milliliters. 3.33 milliliters.
He's going to be finding
now here's a bit more seeable visual representation of a meniscus. So here we are injecting some of the solution into a pipette. Once again, read it at eye level. Read from the bottom of the meniscus at eye level. This volume, initial volume, equals to roughly 4.8 milliliters. We add the extra decimal point to make it 4.80 milliliters. So that would be our initial volume. Now we're going to let out just a little bit back into the other to the beaker. That way we can get our final volume. So we're going to do that.
And this second volume is roughly...
Like I said, the meniscus occurs because the molecules of the substance or stock solution are more attracted to the sides of the pipette than its own molecules.
And this will be your volume delivered. Because you will...
Last but not least, whenever finishing a scientific experiment, always remember to clean up your area and make sure to wipe up any spilled chemicals or substances.